Assalamualaikum and good days. Today I will present about Bernoulli's law for our applied physics project. My name is Muhammad Hafizuddin Hamzah, TE21039. I'm from section 1. My group members Farisha, Azra, binti Ahmad, Tarmizi, TE21007. She's also from section 1. Next is Muhammad Iqwan Hakimi bin Kamaruzaman, TE21037. He's also from section 1. And the final member is Siti Noor Absarina Rohayu binti Ahmad Badri, TE21044. She is from section 2. Bernoulli's principle is an increase in the velocity of a fluid occurs simultaneously with a decrease in pressure or a decrease in the energy capacity of the fluid. This principle can be derived from the principle of energy saving. It states that in a constant flow, the sum of all forms of energy in a fluid will be the same at all points of the flow. An increase in fluid velocity will imply there is an increase in dynamic pressure, kinetic energy, although all energy remains constant. This occurs with a simultaneous decrease in potential energy, including static pressure in internal energy. Next is the theory. Bernoulli's equation can be applied to various types of fluid flows, resulting in various forms of equations. The use of incompressible flow is the simplest form of Bernoulli's equation. An incompressible flow is a liquid and gas with a low Mach number whose fluid density is constant, regardless of the pressure flow. An easy experiment to test Torricelli's law is to use plastic bottles. The plastic bottle should be pierced at the bottom with a small hole. The jet velocity decreases as the height in the reservoir decreases. This is the apparatus that we use in our experiment. First, plastic bottle, then marker, next ruler, screw to make a hole in the bottle, scissor, tape, water, food coloring, stopwatch, and thread. This is the experiment procedure. How our group carrying out the experiment. First, we cut off the top of the plastic bottle. Second, we measure from the bottom of the bottle with a length of 5 cm using a ruler and mark using a marker. Then we hit the screw and push the hot screw through the bottle to make a hole. Next, we repeat steps 2 and 3 to make holes at lengths 7.5, 9.5, 12, and 14.5 cm. After that, we cover all the holes using tape. Then we fill a plastic bottle with water. After that, add a few drops of food coloring to make the water clearer. And the 8th step is measure the water level. The 9th step is we remove the tape at a length of 5 cm for water to drain out. Next, we record time taken by the water flow from start to stop. The 11th step is record the distance of water flow from the bottle. The 12th step is we add water at the same level as before. And the final step is we repeat steps 8 through 11 for the other holes. After that, this is how we conduct our experiment. This is the first hole. And then the next hole. Then the next height of the hole, time taken, and next hole again. And the final hole. This will take a little long. And done. Then this is the second video of the experiment. First hole, second hole. The third hole. The fourth hole. in the final hole. This will be the longest time taken. Done. That's it. How my friends conduct the experiment. Next is result and discussion. First, we discuss the relationship of jet velocity with time and height. When the height of the water from hole increasing and the time taken is increasing, the jet velocity also is increasing because the height and time of the water from hole affecting the speed of the liquid. The height in the reservoir increase, the jet velocity also increase. Next, we plot graph distance versus time, and the last result is determine jet velocity, x component of jet velocity for the system at any height from the graph. Mm, Then we come to the conclusion of our experiment. In Bernoulli's law, the pressure is lower at the constriction where the velocity is higher, and the pressure is higher where the pipe opens out and the fluid stagnates. From the experiments, it can be concluded that with increasing the height of the water from the hole, there is an increase in the time taken, jet velocity, and also distance between the water and the bottom. According to the results, the Bernoulli equation is proved. That's all from me. Thank you for your attention.